Okay, let's go to the next page. Exercise 4, we've seen this example before. Boiling water at 212 degrees Fahrenheit is left in a room that is at 65 degrees Fahrenheit and begins to cool. Temperature readings are taken each hour and are given in the table below. In this scenario, the temperature T is a function of the number of the hours H. So, evaluate T of 5 and T of 8. So we're giving the H, the X value, if you will, the time. What is the temperature? That's what they want to know. What is the temperature when the time is 5 hours? And the temperature at T of 5 is 70 degrees Fahrenheit. And at 8 hours, T of 8, the temperature is 65 degrees. All right, now we're going backwards, and it's asking for the H value. It says for what value of H? It's looking for the H value when the temperature is 104, which is right here, and that's when H equals 2 hours. And explain what T of 6 equals 68 represents. Well, what is 6? That's hours. What's 68? Temperature. So what does T of 6 equals 68 mean? It means the temperature after 6 hours is 68 degrees Fahrenheit. Okay, and the last for this quick little review is just a single function, 4 minus x squared. So we're going to evaluate that for -3 to 3. That's our domain. From -3 to 3, remember domain is your possible x values. And 4 minus x squared. So I'm just going to give you the points that we get here, okay? I'm going to write them in. You can get them from your table. If you go and you put 4 minus x squared into y1 and then go to your table, you should be able to easily come up with the y values that we need. I'm going to do it in my head. -3. I don't have my calculator nearby. -3, -5. -2, 0, -1, 3, 0, 4. Then 1, 3, 2, 0, and 3, 5. I don't even have to graph it to answer what are the zeros of the function. That's where y equals 0. And that is at -2 and +2. So at x equals -2 and +2. Guess what? I can also find the maximum just by looking at the table. That's going to be the highest y value. So that's right here at the point 0, 4. All right, to tell where it's positive or negative or increasing or decreasing, it's best to actually look at the graph. So I'm going to go ahead and graph this function, -3, -1, 2, 3, 4, 5. Go ahead and do this with me if you haven't already. -2, 0, -1, 3, 0, 4, 1, 3, 2, 0, and oops, this was supposed to be 3, -5, and 3, -5. Okay, now we do not put arrows at the end points here because we're graphing it over a specific interval, the domain of -3 to 3. So that's all we're not going to put arrows. We're only going to look at it from -3 to +3 for our domain. By the way, what's our range then? Might as well talk about that real quick. What is our range? The domain goes from -3 to +3. What is the lowest y value? Well, that's right here. These are share the lowest y value, the minimum, and that is at -5. And it's less than or equal to all the y values that are less than or equal to the highest y value, which is at 0, 4. So your y values range from -5 to 4, including -5 and including 4. Okay, state an interval where it's positive. Okay, we are positive when we are above the x-axis. So where is our graph above the x-axis? All of this is. When does that happen? X-axis. Here, it goes above at -2, and it heads below at +2. So our graph is positive from when x is -2 to +2. Not including those numbers, because when x is -2, y is 0, not positive. And when x is +2, y is 0, not positive. And give state an interval where we're decreasing. Remember, decreasing, we're going downhill from left to right. So we're going downhill here. We start decreasing here when